this video, we'll find the domain of a rational function, and then we'll use Excel to explore the behavior of the function at the undefined domain values. So we've been given this function, f of x, where we have a third-degree polynomial in the numerator and a second-degree factored polynomial in the denominator. Part A asks us to identify the domain of this function. Remember, the domain of a rational function is all the x values where the denominator is not 0. We can just clearly glance at it and see that when x is 3 or when x is 10, the denominator would equal 0. So that tells us that the function f of x would be undefined when x equals 3 and also undefined when x equals 10 because it would cause the function f of x to be dividing by 0. So that means the domain of f of x is all real numbers except x equals 3 and x equals 10. Part B says to use Excel to explore and identify the behavior of the functions at the undefined x values. We'll identify if there are any holes or vertical asymptotes. I'm going to draw a horizontal line, and I'm going to put x equals 3 and x equals 10 on my horizontal line. And we've already determined that the function f of x does not have any graph at those two x values. So I'm going to put an open circle there, and I'm going to think about now how to explore the behavior of the function near those values. Basically, we're going to create an input-output table in Excel that kind of sneaks up on each of those x values from both sides. So for example, we know that on the left side of x equals 3, there would be x equals 1 and x equals 2 and then x equals 3. But think about the values in between x equals 2 and 3. There would be, for example, 2.5. Even closer, there'd be 2.9. In between 2.9 and 3, there would be 2.99. Even closer would be 2.999. On the other side of x equals 3, of course, there would be x equals 4 and x equals 5. But I want to sneak up on x equals 3 from the right side. So if we think about getting closer and closer to x equals 3, we could think about values like 3.5, 3.1, 3.01, that's even closer, 3.001. So these values are getting closer and closer and closer to x equals 3. Now we're going to go ahead and look at this in an input-output table. I've created x values, -3, -2, -1, all the way up to 3. But notice, as I got close to x equals 3 from the left side, I inserted those x values that are sneaking up on x equals 3. They're getting very, very close to x equals 3. I did the same on the right side of x equals 3. Close, close, close value is 3.001. A little further away is 3.01. A little further away, 3.1. And then 3.5, 4, 5, 6. I'm now going to define the y value here in Excel. Be careful when you put these functions in Excel. Rational functions, you need to be very careful with your parentheses. When I enter this in Excel, I need to make sure to wrap parentheses around that numerator, and I need to wrap parentheses around this entire denominator, and don't forget that multiplication sign in between the x minus 3 and x minus 10. So here we go. I have equals parentheses around the numerator. 50 times the x value cubed minus 150 and the numerator parenthesis divided by parenthesis around the denominator. Now I'm going to have my factor parenthesis x value minus 3, that's the first factor, times parenthesis x minus 10 parenthesis, and then I close the parenthesis around the denominator. Press enter. I'm going to drag that down until x equals 6. Okay, and as we suspected, at x equals 3, this function is undefined. I'm going to go ahead and just keep that in gray. It says # division by 0 is what that means. So I'm going to go ahead and just press delete on my keyboard so that that cell is actually empty. because there is no function. There's no y value when x is 3. All right, let's explore what's going on here. As x values approach 3 from the left side, notice what's happening to the y values. They're first negative, then they're getting higher and higher, becoming positive, getting higher, higher, higher. They are shooting up towards infinity. So it seems to me that as the x's approach 3 from the left side, this function is shooting upward. It's getting higher and higher and higher. It's shooting upward towards infinity. What's happening on the right side? So if you go to the right side of x equals 3, it's very, very negative. And then it's getting less negative, less negative. It's approaching 0 in height. So it's shooting down towards negative infinity as you get closer to x equals 3 on the right side. So the graph of the function f of x would kind of look like that. It appears there's a vertical asymptote at x equals 3. Now let's do the same thing at x equals 10. At x equals 10, if we want to sneak up on x equals 10 from the left side, we're going to go ahead and put in values like 9, 9.5, 9.9, 9.99, 9.999. And on the right side, you'd have values like 11. Getting closer would be 10.5. Getting closer would be 10.1. Even closer, 10.01. Even closer, 10.001. I'm going to put those values in Excel, and we're going to go ahead and see which y values we get out of this function. So in Excel, I have 9, 9.5, 9.9, 10. It's undefined at 10. Again, I'm going to delete that value out because there is no y value. And then on the right side, 10.1 is pretty close. Okay, so what's going on here? All right, so on the left side, we see x values like 7, 8, 9, 9.5, 9.9. The y values, negative 1,000, and then it's negative 2,500, then it's negative 6,000, then it's negative 13,000, then it's negative 70,000. It's going down, down, down towards negative infinity as we approach x from the left. On the right side, we have values like 11, 12, 13, but as we sneak up on 10, we see 10.5, 10.1. And the values we see here, at 13, it's like 3,000. At 12, it's like 4,000. At 11, it's like 8,300. At 10.5, it's even higher. At 10.1, it's even higher. It's shooting upward to positive infinity. So there is a vertical asymptote. All right, so I suspect, based on what we've seen in this table, that at x equals 3, we're going to see this behavior. And at x equals 10, we're going to see this behavior. Let's go ahead and graph it in Excel and see if we do see those two vertical asymptotes. I highlight the table, insert a smooth line graph, and yes, indeed, that's what we see. Here's our vertical asymptote at x equals 3, and here's our vertical asymptote at x equals 10.